Hello everyone. It is so nice to be live today. And what we are going to do today is I'll solve this diff 3 challenge along with you on this whiteboard. We'll see how it goes, and I'll basically give a lot of pauses during the explanation. So this is the first time I'm doing it. Bear with me. uh, I'll take a lot of pauses, and throughout those pauses, I request you to think through the problems. The idea is I'm gonna learn and I'm gonna teach, and let's see where it goes. So today we have CF CF 1065 div 3. That's the challenge we are solving. Let's look at the first question. I'm gonna read the question and I'm gonna explain it on the whiteboard in just a few minutes. So Corey wants the question's name is Suzuka Hoshikawa and Farm Legs. Corey wants to spend the day with Suzuku. However, the zoo is closed, so they are visiting Farmer John's farm instead. At Farmer John's farm, Suzuku counts n legs. It is known that only chickens, so there are n legs. Let me draw some legs here. You have n legs in the form. Let's say this is leg 1, this is leg 2, maybe this is some other leg, this is some other leg, this is some other leg, and this is some other leg. Count how many legs are there in this image. So there are six legs in this image. One, two, three, four, five, and 6. So there are n legs in the question. You have n legs, and then it is known that only chickens and cows live on the farm. Chicken have two legs and cow have and a chicken has two legs and a cow has four legs. So if there is a cow, there is a chicken, let's say this is the chicken, she has two legs, and if there is a cow, she has four legs. Those are the two animals. Count how many different configuration of John Farmer's of Farmer John's farm are possible. Two configurations are considered different if they contain either a different number of chickens or a different number of cows or both. Note that Farmer John's may contain 0 chickens or 0 cows. So you are given a number n. Let me explain the question. You are given a number n, and then what you need to do is these are the number of legs, and for these legs you have to count the number of what you have to do is you have to count the number of configurations configurations in these configurations. What should happen is there should be x number of hen and plus y number of cows. Now this x and y can be anything. It can be anything greater than or equal to 0. And the idea is, let's say hen is equal to 2 and cow is equal to 4. Then the equation that turns out is 2x plus 4y is equal to n. This n is given to you. You have to find the number of x and y's. Okay, so that is the question. An example would be good. Let's say the first example is, let's say n is equal to 2. If n is equal to 2, then the only combination is there can be one hen. So what that means is number of hen should be equal to 1, x is equal to 1, and y is equal to 0. There's no other combination possible. For if there is 4, if n is equal to 4, then there are two combinations possible. There can be 2 hen and 0 cow, or there can be 0 hen and 1 cow. Now I want to talk about this equation. Let's talk about this equation for a minute. Let's plot it on a xy plane. This plane here represents x and y coordinate. This is x and this is y. Let's say n is equal to, let's say n is equal to 8. Then when x is 0, y has to be 1 and 2. So this will be y intercept. If x is 0, y has to be 2. If y is 0, x has to be 4. So this is the y intercept. Now you draw a line like this. This is what the curve looks like. And all you have to do is determine the points, all the points where this curve touches, where this curve intersects with integer coordinates. So when n is equal to 8, there are a couple of possibilities. First possibility is x is 0, y is 2. Second possibility is x is 1 and y is 1 and x is 2. This is y is 1, y is 1, x is 2, or x is 4 and y is 0. So there are three possibilities for this curve. Now all we have to do is we have to determine the number of points where this curve touches integer coordinates. Now the now the point is the the constraints on n is going to be less than 100, and then t is between 100. So even if you come up with a order n algorithm, even if you come up with an order n algorithm, this question will work out well. So so for the question number A of div 3, I would say just write a code which iterates over y's. Let's say y is equal to 0 till y is equal to n by 4, and for all of those iterations check if there is a possibility of x, and you just write a for loop there. That is one solution we can think. It's a straightforward solution. Try to think of any other solution you can. Okay, I'm gonna rub the board. By this time try to think about the solution. Yeah, so I'm gonna code the brute force solution, and then we try to optimize the solution. So here is the brute force. I'm going to code in Python. You can code in C++ or any other language. This is anyways a pseudocode. So you have a def here, and this is config. farm farm config. This function takes an as input. This function takes an as input, and there's a count which is equal to 0, and then you run a loop for y in 0 to n by 4. This is your y. That's the maximum value. Actually, n by 4 plus 1. Y 0 to n by 4 plus 1. And then what you do is x is equal to, oh, just give me 1 second. Count is 0. Then, so, cow legs, cow legs is equal to y times 4. These are the number of legs with cows. What are the remaining legs? Remaining legs. Remaining legs is equal to n minus cow legs. Cow's legs. N minus cow's legs. Then once you have these remaining legs, you just check if remaining legs mod 2, because there should be even number of legs for hen to use. So if this is mod 2, if this mod 2 is equal to 0, you do count plus plus. Count plus is equal to 1, and here you come and return count. That gives you the number of configurations. Another way to do this, another way to do this would be to see that if let's do a dry run on this. Let's say n is equal to 6. Then let's look at y, cow legs, and count. So initially count is 0, and let's say n is 6. So initially count is 0. First step, y becomes 0. Cow legs become 6. 6 is divisible by 2. So count becomes 1. Then y becomes 1. 1 is the maximum. N by 4 plus 1, that is 2. So you go from 0 and 1. So this range is from 0 to 2 here. Okay, and 2 is excluded, so you just go 0 and 1. For y is equal to 1, remaining legs is equal to 6 minus 4. 6 minus 4 is 2. This is even, so I return count as 2. So there are two combinations. Y is equal to 0. For this, x is equal to 3, and y is equal to 1. For this, x is equal to, this x is equal to 2. Do you notice one thing? Let's do another example before I point something. So just remember, for n is equal to 2, answer is equal to 2. It's for n is equal to 6, answer is equal to 2. Okay, let's do one more example. N is equal to 6, answer is 2. I want you to do this example on your own. You can pause the video if you want, but the next example is, let's say n is equal to 12. So n is equal to 12. Here again you have y, cow legs, um, cow legs. What else? Um and count. So you start with count as 0. Y will go here. The y will go from, this y will go from 0 to n by 4, that is 3 plus 1, 4. So the values of y is going to be y is going to be 0 1 and 0 1 2 and 3. So y becomes 1, cow legs becomes 4, cow legs become 4, 12 minus 4 is 8, 8 is divisible by 2. So you have, let me do remaining legs also. Instead of cow legs, let me do remaining legs. Let me do all four variables. So y, cow legs, cow legs, uh, I'll call it remaining legs, remaining legs, and then you have count. So initially count is 0. Cow legs y becomes 1, cow leg become 4, remaining legs become n is 12, so it becomes 8. It is divisible by 2, so you have count plus 1. Then y becomes 2. Okay, y starts from 0. If y is 0, cow legs is 0, remaining legs is 12. So this becomes 1. This becomes 2 here. Then y becomes 2. When y becomes 2, cow legs become 8 and remaining legs become 4. You can have two hands with four legs. So that's the third combination. And then you have y is equal to 3. The cow legs become 12 and remaining legs become 0. This is the fourth combination. So there are four combinations. For n is equal to 12, the answer is going to be 4. At this point, you should be able to see the pattern. For n is equal to 12, the pattern is the pattern is there are four combinations. For n is equal to 8, we have seen that there were three combinations. For n is equal to 4, there are two combinations. And n is equal to n is equal to 2, there is one combination. N is equal to 0, there is one combination. Can you see a pattern? Let me write it down as n comma config. So this is n comma config. So if n is odd, there is no possibility of a configuration. So n 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for n as odd, n as even, the config is, this is one configuration, 0 0. 1 there is 0, 2 there is one combination, 1 hen. For 3 this is 0. For 4 there are two combination, either one two hens or one cow, and 0 hens. For 5 there is 0 combination. For 6 there are two combinations, either you can have one or 0 cows, and then you have 7 0 combination, 8 3 combination, 9 0 combination. Now try to figure out a pattern here. If you can figure out the pattern, so you will, so all these values, club them together, all these values, club them together. What is the pattern? Can you think of a pattern? The pattern is, if n mod 2 is equal to 1, value is, return value is 0. For odd numbers, the value is going to be 0. For all even numbers, else return n by 4 plus 1. That is your answer. All combinations are possible if n is even. So that's the first question. Just give me 1 minute, I'll close the door. there was there was some reflection on the screen, and I wanted to check it. Let me see if my microphone is working properly. um Details. This is done. This is done. Hello. What is, why is this? Let me check the microphone once. This is external headphone. Hello. Why is it setting it again and again to low power? For some reason, my hello. Yes. So that was my first stream. I wanted to try this format and see how much I can move forward with this format. I'll do a stream every day and let's see how many questions I can do.